factoring quadratic equations. So this is a technique used to solve quadratic equations. So let us try to take an example to illustrate how to factor a quadratic equation. So we will take x square minus 7x plus 12 equal to 0. So when we try to factor this one, we remember that let us simply write the generic form of quadratic equation like x square plus bx plus c equal to 0. Here b is minus 7, c is 12. So we want to express x square minus 7x plus 12 as a product of two factors. So we want to say x plus something, and or let us write x minus something, so we want to write as a product x minus something times x minus something equal to 0. So we are trying to find the factors that can replace this box. So the way to do this one is we try to find the factors for c. So in this case c is 12. So step 1 is to find all the factors for c. So let us write the factors of c as 1 times 12, 2 times 6, 3 times 4, and that's pretty much it. We don't have any more factors for 12. So now the sum of the factors should be equal to b. So here we have b is minus 7. So let us try to see the sum. So when we try to add, we get 13. When we get to add, we get 8. When we add these two numbers, we get 7. So therefore these factors will work for our equation because the sum of the factors is equal to the coefficient b. So now what we are going to do is we are going to express. So let us erase this one now, and then now that we know that 3 and 4 are the factors, we are going to write like this. So minus 3x minus 4x becomes minus 7, and remember minus 3 times minus 4 is 12, so 3 and 4 work. Now we got the factors, then we split our middle term bx into the factors 3 and 4. Now we take these two and these two expressions and try to make common fact. So x is common, so we write x minus 3, and in the second part, let us label this as first and second part. The second part 4 is common, so we get x minus 3 equal to 0. Now we take these two because it is common here and write x minus 3, then we get x minus 4 equal to 0. So our factors are x minus 3 and x minus 4. So we factorized the quadratic equation into two factors using 3 and 4 as the factors. So this is how you typically do the factorization. Now let us take another example for this one. So let us take x square minus 22x plus 72 equal to 0. So in this case our c is 72. So let us write all the factors for 72, which is 1 times 72, 2 times 36, 3 times 24, 4 times 18, now 6 times 12, and after 6 we don't have 7, so we have 8. So 8 times 9. So we have so many factors for 72. So let us see which one works for us. So if I'm going to add this, I'm going to get 73. When I add these two, I get 38. Adding these two gives me 27. Adding these two gives me 22. We can actually stop here because we already got 22 here and we are not interested in any further. So let us circle this one and say that the factors 4 and 18 will work for us, and now we can erase all of them. So we want 4 and 18, so we are going to split 22 as minus 18 and minus 4, because 18 times 4 is 72 and 18 plus 4 is 22, and we are going to write this equation as equal to 0. Now again we take common here, so let us take these two expressions and these two expressions together. So we get x minus 18 minus 4 into x minus 18 equal to 0. So x minus 4 into x minus 18 is 0. So we got 4 and 18 as the roots. X minus 4 and x minus 18 are the factors, and we're able to do. So in all these examples, there is one thing to notice. So the leading coefficient, so when we write x squared plus bx plus c, the leading coefficient is the coefficient of x squared is 1. So this is 1, and we call these as monic. Monic means when the leading coefficient of a expression, leading means the highest degree of the term is 2. If it is highest degree is 3, then that will be the leading. It won't be the first one unless the first term has the highest degree. So we call this is a monic only when the leading coefficient of the highest degree term is 1. So this is called a monic quadratic. So we were trying to use monic quadratic so far to factorize where the coefficient is 1. So the general form of a quadratic is when a is not 1. So here we let us say that a is equal to 1. The general form is ax square plus bx plus c. So we will also try to do an example where the quadratic is more general and not monic. So we will try to see how to factorize a general quadratic equation where a is not 1. So that means we are trying to factorize a quadratic equation like ax squared plus bx plus c where a is not 1. So in this case, let us try to take an example here again. We'll take 12x square minus 17x plus 6 equal to 0. So the general quadratic equations where a is not equal to 1 tends to be slightly complex in the sense that you have to understand and do a little bit more work. So in this case, we are going to find factors of a and c. That means the product of a and c. The product of a and c. That means we will be multiplying these two and then we will get 72 because 12 times 6 is 72. So we are going to find factors of 72, not just c alone. So, and that is the rule. So for a general quadratic equation, you find the factors by multiplying a and c, and for this one. So let us try to find all factors of 72. Again, I think we did in the last time 1 times 72 2 times 36, 3 times 24, 4 times 18, 6 times 12, 8 times 9. So these are all the factors, and we want to find out such that the sum of these two should be 17. So if I add this one, this is 73, this is 38, the addition will be 27, this will be 22, this will be 18, and this will be 17. So we see that 17 is 8 and 9. So let us circle this one because this is the one that will satisfy our quadratic equation. Remember, we factored all of them, found that the sum of the factors did not work for us. The only one that works is 8 and 9. So 8, 9. So that means that if you are very comfortable with your multiplication tables, then you can quickly think about 72 has what factors that make up 17, and 8 and 9 in this case. So let us try to split the b as 8x 9x, which is 17, plus 6 equal to 0. Now we will take the common expressions and then find the common factors. So here see that 4 and x, 4x is common here, so I can write this as 3x, because 4x into 3x is 12x square, minus 2 is 8x. And in the second part we can take 3x. So if I take 3, no, not 3x, just 3 alone. So if I take 3, so I get 3x minus 2 equal to 0. So now let us write the factors. So 3x minus 2 is common here, so we will write 3x minus 2 as a common factor, and we are left with 4x minus 3 equal to 0. So what did we get? We get 3x minus 2 equal to 0, 4x minus 3 equal to 0. So we got factors, and here we get x equal to 2 by 3, and here we get x equal to 3 by 4. So see here that we are not getting integer roots. Here we get fractional or rational roots. So generic quadratic equations where a is not equal to 1 typically might yield these kind of rational factors, rational roots, and therefore the factoring of those will be slightly complicated, like in the sense that you have to do this kind of things, but the technique is still the same. Factoring a generic quadratic or a monic quadratic still has the same rules. That means you try to find the factors. So let us write find factors for the product of a times c. Pick the factors whose sum equal to p. So that is the rule, and then you can split them. So let us summarize that. Monic means for a quadratic a will be 1. A general quadratic is a not equal to 1, and of course a not equal to 0 also, because if a is 0 then it's not even a quadratic. So that is how we try to factor quadratic equations.